Welcome to Pale Blue Pod, the astronomy podcast for people who are overwhelmed by the universe and want to be its friend.
Oh, hell yeah, that's us. Hello, I am Dr. Moiya McTier. I'm an astrophysicist, a folklorist, and science communicator and friend to the universe.
Yes, you are. And I'm Corinne Caputo, writer, friend to the universe, friend to all. Just a big friend. I love friends.
That's your official job title, like your most important job title.
Yes,
friend
exactly.
To all.
Friend to all. I think friends are so important.
They are. They get you through the hard times.
Such a hot take.
I know. Don't cancel us, folks. Friends
I simply
are important.
love friends.
Well, friend, where are we right now?
Okay, we are in a weird spot, but I'm excited for it. We're on the 6 train, and
Yay.
we're riding the City Hall loop. So if you stay on the 6 train after it terminates in Manhattan, for anyone who hasn't taken it, the last stop is Brooklyn Bridge, and it has to turn around. So one of the ways it turns around is it goes through this kind of secret tunnel. You usually have to get off the train. You're not always allowed to stay on it as it does this turnaround. But sometimes you can stay on and you'll see this empty station that used to be used. And we're bending space-time here because we will be recording while we're going through this loop. But I think I figured out how. Usually it takes a few minutes, but we can work our magic.
Well, I mean, we're doing the whole loop.
We'll ride the whole
loop. That takes
loop.
a while.
Exactly.
Yeah.
But I thought it was a good match for our topic today.
It is. Yes, so we're riding to the end of the train. Also, I love that we are on the 6 train. I am moving this week, and I'm moving to the east side, so the 6 train will be my regular train. So it's good for me to get acquainted with it now.
I have a soft spot for the 6 train, too. That was where I went to Hunter College, and 68th Street, Hunter College was my stop.
Nice. I think I've passed by there.
Yeah, that's where they filmed some of Gossip Girl.
Love. Did you ever see the vans parked out? Okay.
I think it was over by maybe not. I had stopped watching it by the time I was in college. But the new Gossip Girl is so bad, but the old Gossip Girl is really good.
Okay. Yeah, I couldn't make it past the second episode of the new Gossip Girl. I agree.
It's actually
pretty
one
bad.
of the worst things I've ever seen, and I watched all of it, and I would have watched more had it continued.
One of my favorite things about being in New York is seeing the vans when people are filming. Marvelous Mrs. Maisel filmed on Columbia's campus, and they parked their vans right outside the physics building. So I never saw anyone, but I did see their trailers, and that made me feel adjacent to fame in a fun way.
I get it. That's such a fun show to see filming, too, because they'll get, old cars and stuff and park them on the street, and then you're like, whoa, is there, a time jump?
But yeah, this is an excellent location because we are riding to the end of the train, and we are talking about the potential ways that the universe might end. So there's that connection. Ooh. Exactly. That feels like a very scary topic. Corinne, how do you feel about this right now?
I'm of two minds here because I think it's very scary to think about the universe ending. I don't like that at all. But that's because I'm imagining that I'm still around for it. And I just, after, recording, I almost said 500,000 episodes of this, which is not true. But
nope. Not at all.
Even close. Half a year's worth of episodes of this. I'm aware now that is very unlikely, or not even unlikely, impossible that I would be a part of this.
Okay, good. I'm glad that doing all of this work with Pale Blue Pod has helped you reach that point. That's fantastic. But I also recognize that for you and for our listeners, this might be a kind of stressful episode. And so I wanted to do something a little different today. Instead of jumping right into the science content, I want to start by giving people some soothing affirmations that they can use if the episode starts to feel like a little bit too much.
I love this idea.
Thank you. So if you start to feel overwhelmed or if you start to feel a bit of anxiety about the end of the universe, feel free to pause the episode and repeat some of these affirmations. I wrote down a few. Corinne, please let me know if you have any ideas. But the first one is actually very similar to what you just said, and it is, the universe will still be around long after I am gone.
That's very sweet to think about.
Yeah, so feel free to repeat that.
The universe will still be around long after I'm gone.
Hell yeah. The next one that I thought of is, at least the universe's death doesn't come with FOMO.
The question mark at the end. Like, maybe some astrophysicists will be sad they couldn't watch it.
No, because, like, I don't know. When I think about death, like, on the personal level, the thing that bothers me the most is that there will still be people around to keep living after I am gone, and, like, I won't get to interact with them. When you're talking about the end of the universe, everything is gone. So there is no, you're not missing out on anything. There's no FOMO here. So feel free to repeat, at least the universe's death
doesn't come with FOMO. My sister-in-law had told her therapist, like, I'm afraid of dying or something. And the therapist is like, well, like, what about it? It's scary. And she was kind of like, I don't know, the not being alive part.
That small part of it.
I don't know, like the concept.
Just the general idea.
But I really like that. I think it is FOMO is what it boils down to, is a bit of FOMO.
Yeah, for sure. The third one I have is, the end is inevitable, and it makes the time we have precious.
Ooh, that's good.
Thank you. It's a bit of a scale, a perspective shift.
Yes.
Yeah, so let's do that again.
The end is inevitable.
And it makes the time we have precious. And the fourth one that I put together is, the universe does not owe us eternity.
Ooh. Yeah, that's... I never thought about that.
Yeah, I mean, we are friends to the universe, right? And friends take the time to consider what their friends are feeling. And, I imagine that maybe the universe doesn't want to be around forever. It doesn't owe us eternal presence, right? So I actually feel more comfortable when I get into the mind space of thinking, like, for the benefit of the universe. And so I like to remember that the universe does not owe us eternity. So feel free to pause at any time, repeat one of those affirmations. Corinne, do you have any messages or affirmations that you might suggest?
This is reminding me that I want to get into affirmations.
Don't we all?
I want to be a person who has habits.
Sadly, I am not.
No, I've been trying to floss for 30 years.
My habit is recording this podcast.
Yeah, exactly. And I think that's only because it's a standing calendar invitation. Maybe we need to have,
that's the point of a habit, is that it's a standing appointment.
But I think that's the accountability of knowing you're on the other end.
So we need to be affirmation buddies, is what I'm hearing.
I think every day at 7, we hop on Zoom and we floss.
Excuse me? Did you just say 7?
I'm going to bed at 9.
I'm getting up at 9 a.m. at the earliest,
This will never work. And this is why I don't floss.
This is why. Because you're a morning person and I'm not. So yeah, those are the affirmations. And now I think we can get into the science part of the episode. Again, just to remind you, we are talking about the different ways that scientists have imagined the universe might end. And a lot of the information that I'm sharing here can be found in a fantastic book that I highly recommend. The author is Katie Mack, Dr. Katie Mack, and the book is called The End of Everything, and then in parentheses, Astrophysically Speaking. Which is great. I love a parenthetical. And like I said, I'm moving this week, so all of my books are in boxes. But when I was preparing, I really wanted to reference this book, and I tweeted out a complaint. And I was like, ugh, I want to do this, but I can't because my book is packed away. And then Katie Mack was kind enough to message me and ask if I wanted a PDF version of the book.
Aww.
So go support, buy this book, learn cool stuff, and support an amazing person and scientist.
I love it.
Yeah. So I want to say up top that thinking about the end of things absolutely is not new. Most cultures have a doomsday myth that describes how the world would end. And for most of history, the words world and universe were pretty interchangeable. There wasn't a clear distinction or scientific distinction between the two. And so they were thinking about how their world, i.e. the universe, would end. But not all cultures had this. Not all cultures have doomsday myths. Not all cultures were interested in thinking about the end. And many believed that the universe was cyclical, so it didn't have an end. It just had like a renewal type of thing.
Like the 6 train.
Like the 6 train, yes, a constant loop. I'd always assumed that it just like, I don't know, changed direction. I didn't realize it was an actual loop.
I think other trains will just switch, like the L train when it ends at 8, just like the platform, you could board on any side and it'll just go back the way it came. But this one is unique. And I don't know if it's like that at the top. I just know it's like that at the bottom.
Okay. All right. Well, we'll see.
We'll see.
So as I was reading this PDF that Katie Mack was kind enough to send me, I remembered that I had read this word when I read the book the first time that I'd never seen before, and the word is eschatology, which is apparently the study of the end of everything, and it's usually used in religious contexts, but can also be applied to the scientific study of the end of the universe. So thank you, Katie Mack, for so many things, but for teaching me a new word.
Yeah.
We started to explain eschatology in the scientific sense kind of in the last century or so, because it's only in the last 100 years that we started to have a better understanding of our place in the universe. It was only around 1920 or so that we even realized the Milky Way is one galaxy among many in the larger universe. And in 1929, we learned that the universe was expanding. So the universe was growing, and that was thanks to Edwin Hubble's observations of very distant galaxies and how they are moving with relation to us. He realized that all of the galaxies we can see are redshifted. If you've listened to our redshift episode, you should know what that means. If not, go listen. And redshifting means that it is moving away from us. So all of the galaxies are moving away from us. And that's not because we are in the center. It's not because we're special. It's because everything in the universe is expanding. All of the space is growing. And once we knew that, we started to think about what the ultimate consequence of that expansion might be. And so scientists have come up with 5 modern hypotheses, and we're going to go through all 5 today.
Yay!
Yay. The beginning of the universe is called the Big Bang. And the hypotheses for the end of the universe, almost all of them have names, or I think all of them have names that start with big, just to be like the opposite. So the first one we're going to talk about is the Big Freeze. Ooh. It's also known as the Big Chill, or sometimes the heat death of the universe, which sounds a lot more scary.
Yeah, heat death sounds scary. Big Chill? That's cool.
Like, I want a big chill right now.
Yeah, I'll take a big chill.
Not this particular big chill, but, like the more colloquial sense of the term.
Like a very large Slurpee or something.
Ooh. I might go to 7-Eleven after this and get a
They
big
just
Slurpee.
closed the one near my house.
Oh, no. There's a 24-hour one near me, so...
I'm sure there's one on one of these stops.
Must be. Okay, so it's called the Big Chill, the Big Freeze, the heat death. So hopefully you understand that it has something to do with temperature. So we're going to talk a little bit about thermodynamics. The field of thermodynamics was started around like the 1700s-ish, and it is the field of science that tells you how heat and energy, those two things are kind of interchangeable, how they move around. So thermo, heat, dynamics, motion. One of the consequences of thermodynamics is that heat will dissipate. It will diffuse or spread throughout a space. And if the space is big enough, eventually that heat or energy will diffuse to zero, so that there's no motion, there's no temperature, there is no energy left in the space because it's all been spread out too far. A man whose title, his official title, was Lord Kelvin, and that's where we get things like the Kelvin's constant and Kelvin instability. We've talked about that before. You could apply for a job as the Lord Kelvin. You actually couldn't apply. This is like back in the times when you had to be born into this shit.
It's a Nepo baby job.
Oh, for sure. So this particular Nepo baby, Lord Kelvin, was named William Thomson, and he wrote in a paper, like a scientific article in 1862 that was called On the Age of the Sun's Heat. He wrote in that article, this is a long quote, so bear with me, "The result would inevitably be a state of universal rest and death if the universe were finite and left to obey existing laws. but it is impossible to conceive a limit to the extent of matter in the universe, and therefore science points rather to an endless progress, through an endless space of action involving the transformation of potential energy into palpable motion and hence into heat, then into a single finite mechanism, running down like a clock and stopping forever. That was a lot. Like, I had to read this sentence, like, 5 times before I understood what it was trying to say. But essentially, it's saying that even back then, even in the 1860s, Lord Kelvin understood that the universe was big enough that its thermal energy should eventually spread out and go to zero. But back then, they still thought the universe was static because we didn't understand that it was expanding until the 1920s. So they thought it was static, but they knew it was huge. And so they thought that this diffusion of energy and heat would still apply.
Mm-hmm.
So then, it's the 1920s, we find out that the universe is expanding and that there's even more reason to believe that the universe's temperature will eventually go to zero. And in my opinion, this is like the gentlest way for the universe to end. This is my preferred method for the universe to end. In my book, The Milky Way, this is the Milky Way's favorite version of the universe ending because it gives us the most time. So here is what would happen during the big freeze.
I'm ready for it.
So the universe pretty much continues on its current expanding trajectory forever. Galaxy clusters become more and more isolated as the expanding universe separates them. The galaxies in those clusters will have time to merge into what I like to call super galaxies. That is not a technical term. But those super galaxies, so like in our local group of galaxies, the Milky Way and Andromeda will collide, the large and small Magellanic Clouds will collide, and all of the other like 50 satellite galaxies will all merge into one big galaxy. That super galaxy is going to use up all of its available gas to make the last generation of stars. Eventually, this is going to take a long time. The last generation of stars will have some low-mass stars and some high-mass stars. We have talked about before that the low-mass stars are going to take about 1 trillion years to just slowly radiate away all of the heat that they create through fusion. But the high-mass stars, the most massive ones, they will turn into black holes. And the black holes are going to live for a very long time, but they will slowly evaporate away through Hawking radiation. You can learn more about that in our black holes episode. And that is going to take like 10 to the 100th power years. It's going to take a Google years, a long time. But then you can take it even further, and you can think about the fact that particles like protons in the universe are going to be carrying their own energy. We'll have photons zipping around through the vacuum of space. Protons and neutrons, they are not fundamental particles. They can still be broken down into smaller parts. Those small parts are called quarks. And physicists have determined that with enough time, these non-fundamental particles will decay into their more fundamental states. And so this is the universe ending with a whimper. It starts with a bang, it ends with a whimper.
Yeah.
And if you take into account how long it would take the particles to decay, estimates show that it would be like 10 to the 1,000th power years.
Whoa.
Before the universe has no energy left in it. So this is an inconceivably long time.
Yeah. It's already hard to imagine the universe with no energy, but I cannot fathom that timeline. Mm-hmm. So I won't imagine any of it because I simply can't.
Right. In the book, the Milky Way is like 12 billion years old. It's been around for a very long time, and it says that even it has a hard time conceiving or like contemplating the long time scales of 10 to the 1,000 years.
Yeah.
Mm-hmm.
I get it.
Yeah. Yeah, so the big freeze, that is just a consequence of thermodynamics if the universe continues to expand the way that it is now. Most of these scenarios have to do with how the universe's expansion is going to act, and that is dictated by the behavior and nature of dark energy, which is so much of a mystery that I don't even want to do a whole episode on dark energy, because the episode would be, hey, welcome to Pale Blue Pod. We're talking about dark energy. We don't know what it is. Bye. Remember, you are space.
Okay, that sounds like the perfect bonus episode.
Well, we just did it. There you go.
This is 2 in 1.
Any thoughts, reactions, questions regarding the big freeze?
Well, so far, it's my number one choice for how we should go out. I'm excited to hear more.
Cool. Hi, it's Moiya, and welcome to this episode's mid-break. Corinne is over there getting some dance tips from those guys who do all the flips on the train. She was really impressed. So I figured now's a good time to give a shout out to our patrons who support this show every single month. Thank you, as always, to our sun-like stars, Sharn Llewellyn, Finn, and Peyton. You're amazing. Every single month, 12 months out of the year. Thank you so much. We also want to thank our newest pre-main sequence star, Augustin. Welcome to the Stellar Club. You too can support us, hear your name on the show, and get research notes for every single episode, all by supporting us on Patreon for just a little bit more than $1 per episode. It's $5 per month. Find the star chart, our Patreon info, and more at our website, palebluepod.com, or go right to the source, patreon.com/palebluepod. And if you can't support us financially, that's totally fine. You are still space, and we still love you. Another really great way to support the show is to help us grow by sharing it with your friends and family. Are you looking for a fun, no-pressure way to learn about math and science? If you are, check out Brilliant.org, the best way to learn math and science interactively online. Brilliant has thousands of lessons in math, science, and data analysis and computer stuff, and they're adding new ones each month. Enjoy fun storytelling, guided problem solving, and making lots of mistakes while playing. On Brilliant, your natural curiosity is going to drive you, not the threat of a test or the pressure of performing well. Brilliant doesn't just teach you facts and formulas and then test you for rote memorization later. They actually help you develop your intuition for these subjects through interactive gameplay. Their science courses can help you get a deeper understanding of the things we talk about on the pod, like electricity and magnetism and special relativity. Or you can branch out to their classes on geometry and foundational logic. But whatever you learn on Brilliant, you're gonna have a fun time doing it. So go to brilliant.org/palebluepod to get a 30-day free trial, and the first 200 people who do that will get 20% off their first annual subscription. Again, that's brilliant.org/palebluepod, or go to the link in this show notes, and that's going to get you a 30-day free trial of Brilliant, and if you're early enough, the first 200 people will get 20% off their annual subscription. And before we get back to the episode, I want to announce a very exciting time of the year. It is time for Multitude's annual survey. This is your chance to give feedback to Multitude as a whole, so for the whole collective, or for each of the shows in the collective that you listen to, like us. So tell us how we're doing, where you want us to do live shows so you can meet us in person, if you have merch ideas, and all of your deep-seated feelings about podcasting in general. Trust me, we really want to hear them. The survey takes about 10 minutes, and it works great on desktop or mobile, and it ends with the biggest collage of pet photos we've ever had in Multitude's history, including a picture of my cat Cosmo. The results of the survey truly help us chart a path for the future, so go to multitude.productions/survey right now to fill out the survey. We're accepting answers until June 9th, so please fill it out as soon as you can. That's multitude.productions/survey, or click the link in this episode's show notes. You hear our voices all the time, so now let us hear yours. Okay, Corinne almost popped her shoulder out of its socket trying to do one of those flips, so I think it's time to get back to the episode. Let's move on to the next one. The next one is called The Big Crunch.
Yum.
Yes. It does sound delicious.
We have talked briefly about the Big Crunch.
Okay, good.
Before.
What do you remember?
I don't remember when, but I just remember thinking that it sounded yummy, and it wasn't.
not yummy. No.
Not at all.
So for a very long time, once we realized that the universe was expanding, we thought that it couldn't possibly expand forever. Surely the gravitational pull from all of the universe's matter would slow it down and maybe even stop the expansion altogether. Maybe, perhaps, there's some balance between gravity pulling in and the expansion pushing outwards that would leave the universe in a static, balanced state, but that would be a really hard balance to strike. Still theoretically possible, but extremely difficult. It's much more likely that if the expansion slows and stops, that it would rebound back in on itself.
Okay.
And so the best estimates that people made back in the day said that this rebounding back wouldn't happen for another several billion years at least, and then it would take time for the rebound to happen. So the rebound starts no sooner than several billion years in the future. But eventually, if the expansion slows down, the universe does rebound and start to contract in on itself. The galaxy clusters that were carried apart by the expansion of the universe would come back together again, and we would start to see a lot more galaxy collisions. This would actually look kind of similar to what we see now in the universe. We see a lot of galaxy collisions already, but they are getting more rare as space gets spread apart.
Okay.
As the universe continues to shrink, its energy, aka its heat, gets more concentrated, and we start to see temperatures that we saw in the early universe. And eventually, it gets so hot, the average temperature of the universe increases so much that stars start to boil away. Yeah.
That is very hot.
That is very hot. Like this is like truly all of the galaxy clusters are coming together. They're smushing together. Space is still pretty big, so you're not going to see individual stars colliding for the most part, but the temperature of the universe is going to be hotter. It's going to be higher than the temperature of stars.
That's so crazy. I don't like that. Too hot.
I'm laughing to deal with the pain. Also, I just think it's like, I think it's hilarious. Something about stars boiling is hilarious to me.
That is not a thing I've ever imagined or thought of because I just have decided so firmly it's impossible.
Right. Well, it is under the current conditions of the universe, yeah. But I love this because I think this is a nice way for people to internalize the fact that boiling happens at different temperatures for different substances, which is something we technically learn in school. But whenever I think of boiling, I think, oh, that's got to be hot, because I think of the boiling point of water, and that's 212 degrees Fahrenheit, which is really hot under 1 atmosphere of pressure. Blah, blah, blah. But like liquid nitrogen, it boils at room temperature, and a star would boil at a much higher temperature. So I just like that it at least reinforces that lesson for me.
Yeah.
So the stars boil away. Eventually the universe condenses back to the primeval atom that started the Big Bang.
Aww.
And then it's just we're all smushed into that one little space. It's essentially like
dense.
All of the stuff that happened in the universe gets rewound.
Yes, that's what I'm imagining.
Yeah.
Like in a movie where you like suddenly pause and like it montage rewinds back to the beginning.
Yeah, so all of the stuff that we've studied about the first like minute after the Big Bang, the creation of particles, the uncoupling of the fundamental forces, the reionization of things, like that happens, but in reverse. So the forces will couple, and the universe will become opaque because it will be too hot, and all of the photons will be bouncing around, and just like cool stuff happening.
Yeah.
I think maybe this is the one that if I could potentially just like leave the universe, which is impossible, but if I could leave the universe and look back to observe one of them, I think this is the one I would want to see.
You'd want to see this one? Yeah, that would be very cool. I think I also, maybe we talked about this, or I saw a video like late on YouTube one night that was talking about like a balloon. Oh, there's a documentary on Netflix about infinity. So I was watching that, and they were just talking about the universe expanding like a balloon, and I think at some point they mentioned that Yeah, and that really helped me imagine the universe expanding and then also contracting.
You got to be careful, though, because when you use the balloon analogy, people think you're talking about the inside, like the volume of the balloon.
Oh, okay, yeah.
But we are talking about the
outside.
surface. Yeah, the surface of the balloon. Let's see. After the big crunch, we have to start thinking about the big bounce.
Cute. Okay, I'm really into these names. Yeah. This is one of the first times I've loved what we're naming things.
It's so cute. So the big bounce was almost a result of like theoretical mathematical solutions. So a bunch of world-renowned cosmologists are people who study, at least in astronomy, cosmologists study the Big Bang and the early parts of the universe and like very, very distant galaxies. So from the 70s to like the 2000s, famous cosmologists, brilliant scientists, used super fancy math to show that a lot of physics problems could be solved if the universe rebounded after the big crunch so that it started to expand again.
Okay.
And like, maybe it doesn't exactly bounce back out. Maybe it punches through that primeval atom to start a new universe on the other side. But the idea here is that after the big crunch, some energy or something makes it rebound again and the universe expands. And in this scenario, the universe would be in a kind of constant pattern, an oscillation, expanding and contracting, big bang, big bounce, big bang, big bounce, over and over again, which I love because it's fun to think about the universe not ending but starting anew. It's also reminiscent of some of my favorite myths from around the world that have a cyclical universe. So like the Mayans, back in 2012 when there was that big fuss about the Mayan calendar ending and so like obviously the world was going to end too, that's not actually what they believed. They believed more that it would be like the birth of a new universe, of a new era, almost. Norse mythology tells us about Ragnarok, which is often described or explained as an apocalypse, an end of the world, but it's actually the end of this phase of the world and a beginning of a new phase. So I like the big bounce because it reminds me of some of my favorite myths.
I like the big bounce too.
It's also really useful to have in my back pocket as a science communicator because I get asked all the time what happened before the Big Bang, and science doesn't really have a good answer to that because our definition of time and space start after the Big Bang. Like our science, our math, it's physically incapable of describing a time before the Big Bang. But with the Big Bounce hypothesis, you have an easy out. You can say before the Big Bang, there might have been a whole other universe that existed and ended.
I love that. It's been a repeating pattern the whole time, and it hasn't been sheer nothingness
the whole time. A delicious, crispy little pattern.
Exactly.
Okay, the next one is the Big Rip.
Okay, Big Rip. I'm thinking pants. I'm thinking accidental.
Yes. Yeah, go follow that thought.
That has happened to me. I was getting out of the car visiting my nephews like a year ago, and my pants fully split down my butt.
Oh, no.
And I was like, I mean, like, I know I've gained weight during COVID, but like, I didn't think I was going to rip through my pants with my COVID ass. And I did.
You know what?
It was like comical.
It's like straight down the middle, like out of a
truly straight down the middle, and like butt is coming out of this seam, like. And that's how my universe ended.
Something similar happened to me in November. I was at a football game with some of my friends from college, and we have a tradition where I always like put one of my friends up on my shoulders. And so I was squatting down so she could get on my shoulders, and everything ripped.
Comical.
It wasn't down the middle like yours. It was like across. It was horizontal across.
Oh, weird.
The legs, like right under my butt cheeks.
Okay, I know what you mean. Like that, like the shelf of your butt is above it. Yep. Yeah, I think what we're learning is they need to make women's pants better. Enough's enough. I need it, or I just need to get actual good pants because I've never done that.
No, they need to make pants better in a lot of ways. Stronger, more durable, more material between the thighs, and more pockets, please.
I am always burning a hole through my thighs. This is enough is enough.
Enough is enough. So the big rip is something we've both experienced. The universe might also one day experience a big rip. Probably not while it's picking someone up.
Yeah, maybe not.
So all of the stuff we've talked about before is based on the expanding universe. But in the 1990s, we got an extra bit of information. We discovered that the universe isn't just expanding, it's actually accelerating. So the expansion is speeding up over time. And this is really counterintuitive. I mean, originally people thought the universe was completely static, and then we learned it was moving, and we thought that movement should be constant. So we keep being surprised. But a lot of people thought that if there is this expansion, eventually it's got to slow down. We still are not sure what is fueling the expansion or the accelerating expansion of the universe, but we have named this force that is responsible for it dark energy.
Okay.
If dark energy is constant throughout time and space, we don't really have to worry about the big rip. On local scales, like galaxies and galaxy clusters, things that are already bound together, dark energy is weaker than gravity, and so the universe does not expand on these more local scales. But what if dark energy isn't constant? What if dark energy gets stronger as space expands? That could happen if dark energy is kind of like an inherent quality of space, kind of like how gravity is an inherent quality of matter. The more matter you have, the more gravity you have. Maybe dark energy is like that, but opposite, where the more space you have, the more dark energy you have. So it would expand even faster.
Whoa.
Yeah.
What if?
That's possible. So in that case, the acceleration would speed up, which I think under like math terms means that it would jerk. So like, here's a little time derivative lesson. You start with position. If you take the way that position changes over time, meaning you take the time derivative of position, you get velocity. If you take the time derivative of velocity, you get acceleration, because that is how velocity changes over time. The way that acceleration changes over time is called jerk in physics.
Okay. I didn't know that.
Yeah. So if the universe jerks, if the acceleration speeds up, then eventually there would be so much space, and therefore strong enough dark energy, that even on local scales like galaxy clusters, space would start to expand. So those galaxy clusters would be pulled apart. Individual galaxies within those clusters would get torn apart. Solar systems, stars, planets, they all get torn apart. And even atoms would be ripped away from each other and themselves ripped apart, so that you're just left with the fundamental particles. This all happens as dark energy overcomes all of the other forces, so gravity and the strong nuclear force that hold our stuff together.
That one sounds scary.
It's terrifying. I think now might be a good time for people to pause and use an affirmation. Katie Mack's book, The End of Everything, has a really helpful timeline laid out for the Big Rip. It's an estimated timeline for when the Big Rip happens, and also when different types of objects would start to be ripped apart. So the Big Rip itself, like after everything is pulled apart, that would happen in about 200 billion years.
Okay.
So it's much closer than the Big Freeze, but still several universe ages away from now. But before that, scientists have estimated when things like galaxies would start to rip apart. So a galaxy like the Milky Way would be ripped open about 150 million years before the Big Rip. So like, for a long time, nothing happens, and then things start to happen very quickly. So 150 million years before the Big Rip, galaxies start to get pulled apart. 7 months before the Big Rip, solar systems start to get pulled apart. 1 hour before the Big Rip, planets like Earth get pulled apart, and just a tiny fraction of a second, it's something like 10 to the minus 17 seconds before the Big Rip, that is when atoms start to get pulled apart. And so all of it would happen very fast, but still 200 billion years away from us.
Okay. Phew.
Phew. Phew. Even us standing here on Earth, like we would see the galaxy cluster getting pulled apart. We would see the stars on the edge of the Milky Way.
That's the moment I'm afraid
we would
of
know
like
it's coming.
Watching it happen, knowing my fate is seconds away.
Yeah. Watching it happen for over 100 million years.
Okay. And that, you know what? In that case, it would be fine to be me, to have a child, a grandchild even.
Yeah. You get several generations. But we don't have to worry about our Earth will be long gone anyway, because our solar system is, like, our sun is going to puff up in just, like, 5 billion years.
The big puff.
The big puff. Oh, I want a big puff right now.
The big puff.
So even if the Big Rip happens, and even if Earth were still there, it would see everything up until the last hour of the universe.
Well, that one's definitely my least favorite so far.
I agree. Well, I'm about to give you another contender for that. Because the next one, I'm going to warn you, is a doozy.
Okay.
I lined these up so that the gentler ones came first, and we end with a
the scariest possible.
The scary ones. So this next one is called the Big Slurp.
Okay, sounds fun.
It does sound fun. It is not fun.
Okay.
So it's the Big Slurp. It's also known as vacuum decay.
Okay, that sounds not good at all.
Right?
Very different.
All right, so we did a whole episode about the 4 fundamental forces. It's episode 13. I highly recommend you go listen to it. The 4 forces are the weak nuclear force, the strong nuclear force, gravity, and electromagnetism. In that episode, we also briefly talked about quantum field theory, which says that particles, not a proton, but like their more fundamental parts, like the quark or a photon or a neutrino or whatever, those fundamental particles, even the ones that carry the forces, can be thought of as excited spikes in an abstract energy field. So like a particle quark is a spike in the quark field.
Okay.
A single electron is a spike in the electron field. And some spikes are more stable and more long-lived than others. So earlier on, when we were talking about the heat death of the universe, and I talked about the decay of these particles, that has to do with how stable these spikes are in those particle fields.
Yeah, I think I get it.
Okay, cool. So that's stuff that we covered in the Fundamental Forces episode. Everything else now is new. Because what I didn't say in that episode is that the forces behave differently under different temperature and pressure conditions.
That's a lot of variables.
Yeah. So there's so many variables in science. So very early on at the beginning of the universe, when all of the matter of the universe was packed into a smaller space and there was more temperature, there was more pressure, the 4 fundamental forces were combined as a single force. And over time, as the universe cooled down, those forces decoupled from each other.
Okay.
So we talk about uncoupling or decoupled forces. That uncoupling happened after a shift in the Higgs quantum field that is related to the Higgs boson particle. You may have heard this referred to as the God particle. I remember back in 2012 when they were like talking about the Large Hadron Collider and we officially discovered the Higgs boson for the first time. People called it the God particle.
I remember that.
Physicists really do not like it.
Some interesting.
Physicists really do not like it when you call it the God particle. But the Higgs boson is a spike in the Higgs quantum field. And when the Higgs field shifted, that led to these forces uncoupling. Each of these shifts came with a new law of physics, or like a whole new slate of physics laws and new forces that could make stuff happen. And so there was once an electroweak force, and then that decoupled into the weak force and the electromagnetic force. Maybe one day the electromagnetic forces will uncouple and there will be an electric force and a magnetic force. I don't know. I'm spitballing here. But the gist of this is that when there is a shift in the Higgs field, new physics becomes a thing. Here's the scary part. Measurements from the Large Hadron Collider indicate that the Higgs quantum field isn't in its most energetically stable state.
Okay.
There is a chance that it could transition to a more favorable state at pretty much any time.
Okay, so like, what is it? The big one in California, like the earthquake that's gonna happen
Right.
at any time.
At any moment. You don't know when it's going to happen. You can't predict it. That's
like
what
that.
could happen with the Higgs field.
I don't like it. I don't like it.
I don't like it either. If that does happen, so like right now, the Higgs field and the interactions that other particles have with the Higgs field give particles their mass. So protons or like quarks, there are 3 quarks in a proton, they interact with the Higgs field more strongly or more directly than the electron does. So the electron is less massive than the proton.
Okay.
Right? Right now, the state of the Higgs field is just right for the mass of things to work out, to like actually bind together and create the universe that we see. So if the Higgs field does suddenly transition to a more favorable state, it would usher in new physics, and under those new laws of physics, the particle bonds that make up the universe might be illegal. So under these conditions, illegal. That was fun to write. So in this scenario, pretty much in the blink of an eye, like we would not see this coming. There would be an instantaneous and like unpredictable reset of the universe. That's it. That's how, like, we wouldn't feel anything. We wouldn't see anything.
Okay.
We aren't, like, this is theoretical, right? So I see it as just like a computer system reboot, right? Where you turn off and you turn back on, and there's a
Everything's
new
different.
update.
And you don't even know.
And you don't even know. The computer doesn't know when you've updated it.
I think is happening all the time. I think that happened on the 2016 election. I think I woke up and I was in a different world. So yeah, I stand with the big slurp.
The Higgs field elected Trump. That's what you're saying.
Yeah, exactly that.
So yeah, that is the big slurp. It would take either a very energetic event or an extremely unlikely event to set it off. It would have to be like a huge cataclysmic collision of something, or it would have to be a very rare instance of something called quantum tunneling, where sometimes particles can just like choose to be in a different state. I don't know. Particle physics seems, especially like theoretical particle physics, goes over my head. I'm not gonna lie. I won't. My pride can take that. That's okay. So yeah, that's the big slurp.
I love that one.
You do?
I really do. Because I think it's just so crazy. Like, maybe that's why I love it.
Good. I'm glad. Yeah. I think it helps that it's like, unlike the big rip or the big crunch, like you don't see it coming. It just happens.
Yeah, I think that's what I like. Of like, I don't see it. It's going to happen. Not that I have control over any of these, but this one is the most like, this is out of my hands. Like this.
Yes, no pain. I like to think that it wouldn't be painful at all.
No.
Yeah. Current research suggests, our current understanding of dark energy suggests that the big freeze is the most likely scenario. It might be the big rip, but we still need to learn a lot more about dark energy before we can be sure. There are observing surveys and missions that different research organizations around the world are doing. The one I am most familiar with is the Dark Energy Survey, where they are looking at, they're like measuring the expansion rate of the universe at different distances. And because space is so big, if you're looking at something farther away, it's also farther back in time. So we're trying to measure the expansion rate of the universe at different times of the universe to see if it has been constant or speeding up or slowing down. We know it has changed over time, but that's because at different points in time when the universe was smaller, gravity could dominate. But now that we're in this moment, we're trying to figure out, what is dark energy gonna do next?
I can't wait.
I
gotta know.
Either.
I hope
That's
I know.
gonna be cool. There are cool discoveries coming up soon, friends, and that makes me really happy.
I do love that. Well, I hope and I'm glad that I will never witness any of these. And, and you know, the universe will still be around long after I'm gone.
Look at you. Look at you remembering the affirmations. Yes, it will. It absolutely will. And even though it's going to end eventually, that's okay, because the universe does not owe us eternity.
So true. And speaking of, they are asking us to get off the train. I can see them signaling.
They're quite insistent.
They're like, actually, it's time.
All right. We'll wrap it up. Thank you.
Thank you.
But whatever train you're on right now, remember, you are space.
Bye.
Pale Blue Pod was created by Moiya McTier and Corinne Caputo with help from the Multitude Productions team. Our theme music is by Evan Johnston, and our cover art is by Shay McMullen. Our audio editing is handled by the incomparable Misha Stanton.
Stay in touch with us and the universe by following @PaleBluePod on Twitter and Instagram, or check out our website, palebluepod.com. We're a member of Multitude, an independent podcast collective and production studio. If you like Pale Blue Pod, you will love the other shows that live on our website at multitude.productions.
If you want to support Pale Blue Pod financially, join our community over at patreon.com/palebluepod. For just about $1 per episode, you get a shout out on one of our shows and access to director's commentary for each episode. The very best way, though, to help Pale Blue Pod grow is to share it with your friends. So send this episode, this link, to one person who you think will like it, and we will appreciate you for forever.
Thanks for listening to Pale Blue Pod. You'll hear us again next week.
Bye.